The information that we have is that given the volume of the box is 540 cm cubed. So since we know the volume is length into breadth into height, so we can say the length is 5w, the breadth is twice w, 2w, and the height is h. So since the volume is 540, we can write 5 to the 10 w squared equals to h. So it is obvious the volume information is given only to find the expression for h. So h can be written as 540 divided by 10 w squared, which is 54 by w squared. This is an expression for h. Now what we have to do is the total surface area of the box is A. So the surface area works like that. Let me show you over here. And if you move it around, you can see that we have this surface 1, 2, 3, and on the other side 4, and then on the here we have 5, and on the other side so 6. There are 6 surfaces over here. The opposite surfaces are exactly the same rectangle. That means this top surface, the rectangle that it is the same as the bottom rectangle. Then the rectangle at the front, it is the same as the rectangle at the back over here. And similarly, the rectangle on the sides, this one, the light red color, and it is the same as the rectangle over here. So we have 6. This cuboid is made up of 6 rectangles, and the opposite rectangles are equal. So this is very, very important to remember. So when we find the surface area, it is adding up of 6 rectangles, area of the 6 rectangles. Remember, volume means space occupied by a solid object. Area means space occupied by a flat object. So if you want to find the area, you have to add up the area of the surface. We can write, so area equals to, so the front surface is 5w into h. 5w into h is 5wh, and since there are 2, one front, one at the back, we can write into 2 instead of adding it twice. Then one at the side is twice h, twice w into h, so that would turn out to be twice wh, and since there are 2 surfaces, into 2, plus one at the top, which is this would be twice w, and this would be 5w, so that should be 5 to the 10w squared. So 10w squared, and that is the area of this rectangle, 10w squared, and there is also at the floor one at the bottom, so that should be equals to into 2. So if we calculate this, this is 10wh plus 4wh plus 20w squared. So let me write the w, 20w squared in front, plus this would be 10 plus 4, 14 wh. Now the expression does not have any h, so what we have to do, the expression we found right over here, 54 by w squared, we can write it 20w squared plus 14w, 54 divided by w squared, and it turns out to be 20w squared. I don't have to calculate, it is clear, it would be 756. So this w and this w cancels, it would be 756 divided by w, and our expression is proved. So question number A deals with showing proving an expression of what would be the area of this box can be expressed in terms of w. The majority of the mark deals with question number B, C, and D, which is altogether 9 marks, and this is only 4 marks. So let's start with question number B. So question number B, we have to find the value of w, where we have at the minimum value, that means the gradient is 0, dA by dw. So let's find the value of the derivative. So this is 20w squared plus 756 w to the power minus 1. It is important to bring the variable upstairs. So the derivative is going to be dA by dw equals to 20 into 2 is 40w, then 756 into minus 1 is 756 into minus 756, w to the power n minus 1, this would be w to the power minus 2. So at the minima, the gradient is 0, dA by dw equals to 0, and we have to find the value of w to 3 significant figure. So this is 40w minus 756 divided by w squared. That would be a good idea for the calculation to bring it downstairs again. So this would be 40w equals to 756 by w squared. Therefore w into w squared is w cubed, and this is 756 divided by 40. Therefore, W would be cube root of 756 by 40 equals to, shift this is cube root, this would be 756 divided by 40, bracket closed. So this is going to be 2.6637. 2.6637. So the answer would be W equals to 2.66. Question number C. Question number C, we have to prove that it is indeed the value of W that we found would give the minimum value of A. So whenever we have to prove that, it is the second derivative. So second derivative, meaning derivative of the derivative. So the first derivative was dA by dW equals to 40W minus 756W to the power minus 2. When we differentiate this again, this would be d2A by dW squared. So 40W would be 40. Now minus this, let me keep the minus 756 here as a constant. So this would be minus 2W to the power minus 3. The n comes first and the power decreases by 1. So this is the value. So this is going to be 40 plus, minus into minus is plus. So this would turn out to be 756 multiplied by 2, which is 1512, and W to the power minus 3. It is easier for calculation if you bring it downstairs and make it positive. So we know the value of W cubed over here. We don't need the value of W exactly. We have W cubed over here. So I'm going to use that value. So W cube is 756 by 40. So at W cube equals to 756 by 40. So we can write over here. So d2A by dW squared equals to 40 plus 1512 divided by 756 by 40, and this is a positive value. So you can either calculate or not calculate, it doesn't matter. So I'm calculating over here 756 divided by 40. This is 80 plus 40 is 120. So we just need to know whether the second derivative is positive or negative. So you write, since d2A by dW squared is greater than 0, it gives minima or minimum value. That's it. That's the verifying, or that's the proof. Now question number D, we have to find the actual value of A, which is from the equation, from this expression of A. So at W equals to 2.66, that is the value of W over here. So we can write A equals to 22.66 squared plus 756 divided by 2.66. I must add, it's a good idea to take more than 2.66. You should take 2.6637 to prevent rounding off error, because the answer would be more accurate if you take more values of W. So this turns out to be, so 20 into 2.66 squared and plus 756 divided by 2.66. So this turns out to be 425.7, but the answer has to be in the nearest whole number. So we can write 426. So 426. That is the answer. That is the minimum value of A.